working as a desktop support engineer since last 5 years.
Oh, great.
So to I want to learn AWS DevOps, any cloud, and
Nice.
yes.
Nice.
Ramesh?
Ramesh, Ranjit, Avinash, Gopinath, anyone?
Ramesh, can you brief about yourself? Gopinath?
Yeah, hi.
Yeah,
Hi.
hi.
Can you brief about your profile, please?
Yeah, this is Gopi, and I'm working for one of the product-based company,
Nice.
and I'm having 10 plus years of experience. And I started my career as a engineer. Post that, I migrated myself into coding,
Nice. Nice.
and now I just wanted to migrate myself from coding to non-coding environment. So that's the reason I'm choosing this.
All right. Okay. Hi, good Sevak.
Yeah, hi, sir. How are you, sir?
I'm good. I'm good. How are you?
I'm good, sir. I'm absolutely fine.
You are?
I'm good, sir. I'm good. I'm absolutely fine, actually.
Oh, great. Great. So, can you brief me about your profile? We will start in a minute, right?
Avinash?
Avinash,
Hi, Ganesh.
hi. Your voice is,
This is
yeah, please go
okay.
ahead.
Okay. My name is Avinash, and I'm calling from Pune, Maharashtra.
Jai Shivaji.
Jai Shivaji. So I have near about 10 years of experience in Linux administration and 5 years of experience in AWS administration.
Nice.
So I want to migrate from current position to DevOps position. So I'm planning for DevOps.
Great, great, great. Vishwa, hi.
Vishwa?
Okay. Yeah, please go ahead, Vishwa. Yeah.
And Ranjit?
I think we should be starting,
Yeah,
Ganesh.
yeah, we can.
Okay, hello, hi, and welcome to this session on the introduction to AWS and DevOps. So some of you are from the ops background, as we say. Welcome everyone. Let's start by sharing my screen, and some of you should be telling me if my screen is visible to you or not. Any one of you can answer.
Yes,
Yes, it is visible.
it's able to be. Yes.
Okay, and let's see. So welcome to the DevOps training by the Shun Technologies, and my name is Ram. I am your trainer. So before we start the session, let's have a brief introduction about me. My name is Ram. I am your trainer. I am working as a DevOps engineer with a reputable MNC from past 8+ years. I have around training experience of around 6 years. As you can see, I am AWS Certified Solution Architect Associate as well as Microsoft Certified Azure Administrator Associate. So those are the two certifications. One I got from Microsoft, one I got from AWS or Amazon. So I also conducted corporate trainings with entity data intelligence and VSIT. My training mode is always hands-on, practical, based on real life scenarios. And then this is my passion to teach people. It's not like full time, but but I do work and train people simultaneously. That's how it is. That's the brief introduction about me. So now let's not waste our time and dive into the world of DevOps. So you might have heard about this word a lot. DevOps, DevOps, DevOps. Everyone is saying DevOps. You want to migrate, have better chances. Ops people go to DevOps. Administrators go to DevOps. Even developers nowadays, they're asking to go for DevOps. Even I have seen some of the data engineers who are migrating into DevOps. So what is this DevOps basically? DevOps is not a tool or a software. It is basically a set of rules. A set of rules that are established for communication, or set of tools that are used with each other so that we can make the software releases easy. Earlier, these DevOps engineers used to be called build and release engineers. Build and release engineers. So the build and release engineers were actually doing the CI/CD, continuous integration and continuous delivery. But nowadays, what happened is they want to bring together developers and operations so that there is a smooth flow of the particular software that is ready for the release. So what happens in the world of DevOps? What happens in the world of DevOps is the question that we need to answer first. So you all know the software development life cycle, right? Most of the companies which you're working with, either product-based or service-based, any companies you work with, focus on one thing. What is the one thing they are focusing on? They are focusing on sending out a proper software. Those software can be utilized by the customers in the market, or we will be making software for people who are selling out that particular software. So all of you use Androids or iPhones, right? Yes or no? Androids, iPhones. So you all have the operating systems in here. For example, there is Android 11. That is the Android 11. Is that the version, the current version, 11 or 12? I don't know. 11, I guess. So iPhone is on 18 point something, 18.0.1 or something. I'm using an iPhone. So what are these things? These things are called versions, basically. These things are called versions. What are the versions of a particular software? Anyone? Can we talk? Can we have a two-way communication in here? Yes. It makes the session interactive. You will also be finding it wonderful if you are collaborating on here. If you are shy about recording, we can stop the recording and we can continue the demo. Anyone? So what are the versions generally? So versions basically are what? The advancements of the software. For example, let us say, and let us take iPhone. Nowadays, you're getting so many things inculcated into it. AI is coming, and then there are new features coming with every other release. The stability is getting increased. The security of the software is getting increased day by day, right? Security of the software is increasing day by day. What is happening here? We are inculcating more and more and more and more features. Also, we are mitigating the bugs that are there with the versions. Earlier, what used to happen? Earlier, what used to happen was, even if it is waterfall model, even if it is agile model, if it is waterfall model, what used to happen? Your business analyst goes and gets the requirement. The coding happens. Once the coding happens, testing happens. Once the testing happens, build happens, and then ready for the deployment. Ready for the deployment. It is a one-way process. There is no going back, coming here. And then there are so many teams that are involving in here. For example, the coding will be done by the developers. The testing will be done by the testers. The remaining everything will be dealt by the ops people, right? And there was no proper communication between the teams that is happening, which made the releases difficult. So then what they did was they focused on how to send the software out properly, or efficiently, and they came up with something called Agile model. In the Agile model, they have the Scrum. In the Scrum, what they used to do, they used to divide the entire work into sprints, bi-weekly sprints, weekly sprints, and they used to have weekly targets, and they used to make the weekly work done. And then they used to integrate the small chunks of work that happened into a proper software. This is called building problem, if you ask me. So in this also, what happened, the communication between the teams was difficult. When the communication between the teams was difficult, what they used to do, they used to set up meetings, they used to talk to each other, but still the communication is lagging, and everything was done manually. When everything was done manually, there is a high chance of the process being slow, or the high chance of error. So they did what? They have inculcated automation into everything. They have inculcated automation into everything. Once the automation is there, once the developers and the ops people are talking to each other, DevOps came into existence. Usually, what will your developer focus on? Developer will be focusing on what is the next update. What is the next update? How to code this particular thing? How to code? Is the code properly getting integrated? Is it properly running in my environment or not? That he will check. What will ops people do? For example, we are developing a small website. Let us say. So this website will be hosted on a particular server. For example, say web server. And once it is hosted on the web server, it is available for the world. So now ops people will do what? They will take the website and put it in a server so that it runs properly. So then what happened? Then there used to be problems here. It was running fine here, but there used to be problems here. So the ops people completely focus on the operations, how to manage the servers, how to make the infrastructure for the servers, how to facilitate whatever software is going out. Everything they will be focusing on ops. Devs will be focusing only on the development. Then what happened? Then the communication between the teams and the involvement of the teams has become a hindrance for the release. So they came up with something called DevOps. DevOps is a set of principles and code and tools that are running together so that the release flow is proper. And when you see the diagram, when you see the diagram of the DevOps over here, you can see an infinity symbol. This is called infinity. What is this infinity symbolizing? This infinity is symbolizing the continuous process. Continuous process. What is the continuous process you are talking about, sir? Now I will talk about that thing. For example, in DevOps, what happens is there are so many tools that will be coming into picture. So when you enter into the world of DevOps, which has infinite potential to create versions and versions and versions, how this thing happens? So everything in a project starts with a planning phase. In the planning phase, for example, let us say we are developing a calculator application. When you are developing a calculator application, what do you need? You are going to need a screen where the numbers are displayed. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you are going to need a 0. And then you are going to need an equal to symbol. And then you are going to need an all cancel button. And then you are going to need a plus, minus, into, division, modular division. These are the particular things you are going to need. So according to your particular requirement of the calculator, what you will be planning, which platform am I going to develop with this software with, what are the things that I am going to need here, what are the different other things, what are the requirements, everything will be planned. According to the plan, your developers will choose some platform according to the company norms. For example, on the Java, they are making this calculator. So they are going to write the code in Java. So there are so many developers who are there, right? They will be writing small chunks of code so that this particular application can be developed. Now, all these chunks of codes are integrated in the build stage into one file called artifact. This particular artifact is a jar file or a var file or an EAR file or an EAR file or EXE file, MSC file, like this, different types of files are there. So they will be building it. Once the building is done, the testing is done. Also, on the code that is written here, the code quality test is also done. Code quality test. So once it is done, after testing, it will be ready for the release. Once release, they will be deploying it onto the servers. And then your particular calculator application is almost all available for everyone who is on the internet. Then they will be operating this calculator and then monitoring the working of this particular calculator. And when they are monitoring, for example, my equal to button is sometimes not working, 7 button is not working sometimes. So like that, they will get bugs. And also tomorrow, somebody science student came and they wanted a scientific calculator. They are going to need sine, cos, everything into this. So they will also give me the suggestions for the new set of things that are going to need according to these things. So the version 1 is over now. Version 1 is deployed. So for the version 2, the planning starts and the coding starts, building starts, test, deploy, operate, monitor. And then again, for the version 3, I'm going to get everything. Then I will make version 3, version 4, version 5, version 6. Like this, I am going to make this continuous thing. And then when the process is continuous, you need to understand that there are so many tools that will be coming into picture over here, right? So how does this DevOps flow work? Once you see the DevOps flow work, you will understand everything properly. So for example, first there is a requirement. According to the requirement, what happens? A ticket will be raised to the developers. And according to the ticket, the developers will be writing the code. So, for example, I have 10 or 12 developers in my company. Everyone is writing code. Everyone is writing small chunks of code. And all these chunks of code are pushed into a repository that is hosted on repository hosting services like GitHub. What is a repository? Repository is basically a folder that is existing on cloud or on the internet. Simple. So now all the small chunks of codes, whatever they have written, will be placed in the repository on GitHub. This GitHub is connected to something called Jenkins. This is like heart of your pipeline. This is where the continuous integration and continuous delivery happens. Some people call it deployment, some people call it delivery. No problem, you can call it both ways. So here the continuous integration happens. What is integration? Basically, integration is you have the small chunks of code that is written in Java, right? You take all these and integrate into a big chunk called artifact. So for that, you are going to need something called Maven. Something called Maven. Maven is a tool that is build tool. So this build tool has the capability to integrate all these small chunks of code into a big artifact. But before doing that, Maven has a connection with something called Sonar Cube. This Sonar Cube is used for the code quality testing. For example, your developers are writing the code. The code quality is set for 98%. So now when the 98% threshold is met, all these small Java file chunks are integrated into a jar file at Maven. So then if the code quality is passed, it will tell Maven to build the artifact. Once the artifact is made, the dependency check will be done. What is this dependency check? There is a vulnerability scan that happens on the jar file. There is a vulnerability scan. Once the vulnerability scan is complete, then it will go into the repository or the artifactory. This is called artifactory because you store artifacts in it. Nexus or JFrog will be the artifactory that is there. Once it is on there, version 1 comes. And then for hosting this particular jar file, you have the jar file now. You have to keep this jar file in a server so that it runs, right? Instead of using the entire server for hosting, we are going to use a small chunk of it called container. And for the containerization, you have a tool called Docker. So the artifact is given to the Docker, where building and tagging of the particular thing, particular container is done. Then there is also a tool called AquaTrivi, where pen testers, security people will come into picture and scan the vulnerabilities of a particular container. Once the containerization is ready, it will be sent into the Docker, and Docker pushes that particular container into the Kubernetes for deployment. So Kubernetes basically container. What is a container? Container is nothing but a small environment where your code runs properly. So like this, so many containers are orchestrated by using something called Kubernetes. Once it is ready on the Kubernetes, what happens? This is monitored. For monitoring, we are going to use the tools like Prometheus, Grafana, etc. Grafana, etc. And then the pen testers will also use a tool called Zap to perform the pen testing. So now, if you see here, you can see multiple number of tools that are coming into picture. So where are these tools sitting? They are sitting on Linux servers. And for these Linux servers, you are going to use for maintaining these Linux servers. You cannot, like, for example, if you take a project, you have around 10,000 servers. You cannot individually go to a server and manually work, right? So that is why you have a configuration management tool called Ansible. Okay, fine, sir. There is Ansible, there is Linux. You are saying all these tools will be present on the Linux servers, and the Linux servers will give me the capability to run all these things. Where are these particular servers sitting? These particular servers are sitting on a cloud architecture like AWS, Amazon Web Services. Again, for maintaining a huge infrastructure, you cannot go to the AWS console and do everything one by one, right? That is why we are going to need an infrastructure as a code tool. And the infrastructure as a code tool we are using is Terraform. Terraform is the infrastructure as a code tool. Give me a second, please. Okay. So now you're going to need an infrastructure as a code tool called Terraform. What will Terraform do? Terraform uses something called HCL language, HashiCorp language. Using this HashiCorp language, which is a structured programming language or the data serialization language they call it, because everything will be in the format of key value pairs. If you see here, you can see the code that is written on the Terraform. We have already written some Terraform code over here. So if you run the code, the particular resource will be provisioned on AWS. Like this, you will be having different tools that are there. So now there are so many tools. How will I know where to start? So basically what you will be doing is, what are the daily roles and requirements, roles and responsibilities, that also we need to talk about, right? So what are the daily roles and responsibilities of a DevOps engineer? The daily roles and responsibilities of a DevOps engineer depends on what project are you working on, depends on what work you are doing. For example, there are some people who are cloud automation engineers. So for them, they are going to need Terraform plus EKS, Elastic Kubernetes Service, or Terraform plus Docker. Some people will be working on. Some people will be working on Jenkins, Ansible, Terraform. So really depends on what project you are working, what things you are doing. So now the next thing you have to understand is, where do I start learning all the DevOps, because there are so many tools that are involving in this. So first you have to start with something called, there are three musketeers of your success. What are the three musketeers of your success? The three musketeers of your success are Linux, some cloud expertise, and then the DevOps tools. So in the Linux, when you meet people nowadays from the trainings, they will be saying Linux basics are okay. No, you have to do complete Linux system administration plus server administration. Linux system plus server administration, because all the tools we have spoken about until now are working on the Linux servers. So you are going to need how to particularly do anything with a Linux server. Basically, you have to know the server behavior properly. So Linux system administration, server administration, we will do. And for automating the regular boring tasks, we are going to use something called bash scripting. We are going to learn bash scripting. Then we are going to learn AWS, and in AWS, we will be learning around 12 to 13 services that will cover the complete solution architect associate level. Next, we will be learning Terraform. Because once you have learned the AWS properly, it is easy to learn the Terraform because it is automating the AWS infrastructure. Then you are going to learn Ansible, where the configuration management tool automates the Linux. Ansible uses a language called YAML, which is YAML ain't markup language. So the next thing we are going to learn is Git. Then you are going to learn Maven, Jenkins, SonarQube, and then you are going to learn Docker, then Kubernetes basics. Like this, you are going to learn everything completely. So now integration between Jenkins comes into picture. So usually I have explained you the entire pathway for DevOps, right? Now let us understand how these things work. So Jenkins sits in the middle, and Jenkins is configured with every other tool which you have seen in the master-slave architecture. They call it master-slave architecture. And inside Jenkins also, you can run either freestyle projects or you can run pipeline as code with Groovy. Pipeline as code with a scripting language called Groovy. So all the tools will come together. First, you have to learn every tool and every functionality, and then you have to integrate everything inside Jenkins so that your complete pipeline comes into picture. How many projects are we going to do in this particular course? We are going to do 2 projects. One is for the CI part, one is for the CD part. So with CI, continuous integration, continuous delivery using Docker and the basics of Kubernetes, we will be seeing. If you want to learn Kubernetes completely, it is around 10 hours of additional learning. How long is the course going to take is the next question that comes into picture. The next question is, we are going to need 2.5 months or nearly 3 months for finishing this particular course. So this is about the demo of Linux, AWS, and DevOps. If you have any questions now, you can ask me. You can stop recording, Ganesh. If they have any questions, they will ask me.